All right, in this video, we're going to discuss the notation for arcs and central angles and discuss the different types of arcs that we have, and then we will apply the relationship between arcs and central angles to a couple problems. So in the first one, or this first row, we have what's called a minor arc, and a minor arc is an arc that is less than 180 degrees. So I'm highlighting what would be considered a minor arc. When we name a minor arc, we use two letters, which are the endpoints of the arc. So the arc I highlighted in maroon, I would call arc CA. And I could also call it arc AC as well. And we learned in the discovery activity that the measure of an arc is equal to the measure of its central angle. So this would be equal to the measure of angle COA. Now, a major arc is an arc that is 180 degrees or more, and the way we differentiate between a minor and a major arc, we name them, is we use three letters with a major arc. And so if I highlight my major arc in this picture, it would be arc CBA. And I could also call it arc ABC. As long as the endpoints are the first and third letters, then I would just pick any point that's between those two endpoints. And just like before, an arc, whether it's minor or major, is always equal to its central angle. Now, when we talk about these two central angles, for this major arc, we're really talking about the central angle that's greater than 180 degrees. Whereas up here, we were talking about the central angle that was less than 180 degrees. And then we learned the day prior that a semicircle is an arc whose endpoints lie on a diameter, and a semicircle is equal to 180 degrees. A semicircle is considered a type of major arc, so it is named using three letters. So I will call this arc ABC, and it's equal to 180 degrees. And likewise, I also could have called it arc CBA. And then lastly, we have a central angle, which is an angle whose vertex is at the center of the circle. And so I would call this angle COA. And once again, it's equal to its arc, which is AC. Now, one more theorem that we're going to use to apply properties of central angles and arcs is that we can add arcs together, just like we can add angles together and like we could add segments together. And so what arc addition basically means is if I take arc RP and I add arc PQ, these two arcs add together would be equal to arc RQ. And so if I say that arc PR is 30 degrees and arc QP is 50, then arc QR has to be 80 because I would add the two arcs together. All right, so in this example, let's just practice identifying whether we have minor, major, or semicircles. So here I have arc AE. So if I highlight this, I can tell this is a minor arc. If I look at arc F to D to E, this is going to be a semicircle. And if I look at arc FA, this is going to be a minor arc. And then lastly, if I look at arc D to F to B, this is definitely bigger than 180, so this would be a major arc. All right, so let's apply the relationship between central angles and their arcs, which we know that they're congruent to each other, to a couple problems. All right, in this first example, I'm giving that the central angle ADB is 50 degrees, and I notice that CDA is a straight angle, meaning it's 180 degrees. And I notice that 50 degrees and angle CDB are supplementary. They form a linear pair. So 180 minus 50 is 130. So which means this arc is 130, this arc is 50, and then this arc is 180 degrees. So if I find the measure of arc AB is 50. Arc BC is 130. Arc AEC is 180 degrees. And arc BCA. So BCA, I'm going to highlight it. I'm going from B to C all the way around to A. So I want that whole arc. And so I have two ways I can do this. I can add 130 plus 180 to get 310. Or I don't need the 50 degree arc. So I could do 360 minus 50, which also gives me 310. So what I want you to do is I want you to try this next problem. I want you to find all of these arcs. I want you to pause the video, try finding all of the arcs with the information that's given, and then once you've come up with all 10, unpause the video, and then I'm going to just provide the answers and you can see how you did. All right, so hopefully you feel pretty confident with what you've done for this example. There's just one thing I kind of want to point out to you, or a couple things I should say. If you struggled getting started, hopefully you realized that these angles here, I'm trying to highlight them. The 70-degree angle is vertical with the angle opposite of that. So you really needed to recognize you had a set of vertical angles to add the 70 in, because if you didn't recognize that, you wouldn't have been able to come up with the other central angle measures. And then the problems that I circled are ones where you needed to perform some calculations, whether you were doing arc addition or you were maybe doing 360 minus the arc that you didn't need. So hopefully all of those make sense, because what we're going to do now is we're going to take a look, and now we're going to think about how do we apply things algebraically. So in this example, it says find the value for x and then find the measure of arc BC. So the one thing I notice is that this is a diameter, so that means I have a semicircle. So since I'm looking at this arc here, which those are the two pieces I have an expression for, I know that semicircles add to 180 degrees. So I know that arc AC plus arc BC have to add to 180. So x plus 2x minus 30 equals 180. And then if I combine like terms, I have 3x minus 30, add 30 to give me 3x equals 210, divide by 3x equals 70. So since this angle or this arc was just x, I know x equals 70, arc AC is 70 degrees. I was asked to find arc BC, so arc BC is equal to 180 minus 70, so arc BC is 110 degrees. So let's take a look at our last example. In our last example, we're given expressions for all of the arcs that make up the circle. And so I have to think to myself, well, how many degrees does a circle add up to? And I know that's 360. So I know that arc RS plus arc ST plus arc TQ plus arc QR, so all of the arcs have to equal 360 degrees. And because I have an expression for all of those arcs, I can just substitute them in. So 6x plus 7x plus another 7x plus 4x equals 360. So 6 plus 7 is 13, 13 plus 7 is 20, 20 plus 4 is 24x, and that's equal to 360. Divide 360 by 24, and we get that x is 15. So it then tells us to find the measure of all of the central angles in the arc. So I'm going to substitute 15 in. And so when I substitute 15 in for 4x, that gives me 60. 15 in for 6x would give me 90. And then substitute 15 in for the x for 7x, that would give me 105. So this one here is also 105, which means my central angles are going to be the same as all of their arcs. And if I want to know if I'm right, if I take 60 plus 90 plus 105 plus 105, it should equal 360, and it does, so I know that I solved my problem correctly. So you are ready to now try the lesson 2 practice on your own.